Hello and welcome to iStream Ophthalmology, learning ophthalmology made simple by Dr. K. Suresh. Welcome back to iStream Ophthalmology. Today we are going to learn about toric transposition. So, what is this toric transposition? So, any patient who requires glasses for correcting their refractive error are prescribed two types. One is a purely spherical correction, which can be either a minus or a plus depending on whether they are a myopes or hypermetropes. But invariably, most of our patients also have astigmatism. So this astigmatism requires what is known as a spherocylindrical prescription. Correct? But the spherocylindrical prescription, something like this, +1 diopter sphere, +3 diopter cylinder at 90. A very typical spherocylindrical prescription. But it does not reveal the individual surface powers of the lens that is being manufactured. So our toric transposition is a method which describes the exact surface powers of what the lens has to be, how the lens has to be manufactured. So as I already told, it is essential for lens manufacturing to know exactly and precisely how much power must be ground on each surface of the lens. So to express this, toric transposition breaks the prescription into three components. So what are these three components? One is a spherical surface power. Okay. Another is the base curve and what axis it has to be, and the cross curve and what axis it has to be. I will tell in detail about all these components subsequently. Okay. So what is this toric transposition used for? Primarily for lens production factories and by optical laboratories for surfacing a toric lens. Before going to learn how to do a toric transposition, we must understand what this means. That is a torus. A torus is nothing but a mathematical representation of something which mimics our tire, our car tire or a cycle tire, something like that. A structure which is similar to that is known as a torus. Okay, so if you look at a torus, it has two curves. Okay, this is the bigger curve or the weaker curve, and this is known as the base curve. When we talk about any toric surface, there is one base curve or the weaker curve. Okay, and that is what is named as the base curve. Any curve which is perpendicular to that and has the maximum curvature is known as the cross curve. Okay, so in short, any toric surface has to have two curvatures. One is the weaker curve known as the base curve, and another one is the cross curve, which is a more prominent one or more stronger one. So let me reiterate it. The anatomy of our toric lens surface has two curves, the base curve and the cross curve. So base curve, how do you define a base curve? It is the principal meridian of the weakest power of the toric surface. So it is the weakest power of the toric surface and is the foundational curve upon which the rest of the lens geometry is calculated. So the base curve is the foundational curve for our toroidal surface. Next comes the cross curve, which has a greater power and it is 90 degrees or perpendicular to the base curve. Okay, so the base curve and the cross curve must always be 90 degrees apart. Okay, having learnt about the different curves, now let's see what is a toric lens. The toric lens has two surfaces. One is the spherical surface and one is the toroidal surface. Toroidal surface already we saw. So what is the toroidal surface? it has two principal meridians. One is more curved than the other. And as I already told, the weaker or the principal meridian with the weaker power is known as the base curve, and the principal meridian with the stronger power is called the cross curve. So in short, a toric lens has one spherical surface and one toroidal surface. In this toroidal surface we again have two curves, which is one is a base curve and one is the cross curve, and the difference between the cross curve and the base curve will always be equal to the cylinder power of our prescription, which we will see subsequently. So what do we want to achieve by doing a toric transposition? We want to achieve this formula or this result. This is the basic blueprint of a toric transposition prescription. It has to describe the anterior spherical power, and it has to give the details of both the base curve and the cross curve of the posterior toroidal surface. So finally, after doing our toric transposition, we must have one numerator which contains the anterior spherical surface, which basically represents the parent spherical lens. And what is the denominator? It has two components, the base curve and its axis and the cross curve with its axis. This represents the toric carving that has to be done at the posterior surface. Though toric rules like this are written as a fraction, please remember the numerator just says about the spherical power and the denominator just tells about the base curves. They are not mathematical formulas. And we must not use these numbers to do any mathematical equations. They are just representations of what the anterior spherical power is and the posterior curvatures of the posterior surface. So earlier we learnt about something known as a simple transposition. Now we are learning about toric transposition. So what is the purpose of both of these? Okay, simple transposition is nothing but a clinical formatting, just expressing the same prescription from one type of cylinder into another type of cylinder. If you have a plus cylinder, just converting the prescription into a minus cylinder form, or if you have a minus cylinder, converting the same prescription into a plus cylinder form. Okay, there is no physical alteration, because ideally the simple transposition must not create any physical alterations in the lens. Okay, now let's come to what are we trying to achieve in a toric transposition. Toric transposition is essential for optical manufacturing, because the person who is going to manufacture the lens has to know what must be the power of the anterior surface of the lens, what must be the power that has to be ground in the posterior surface of the lens. Is it a spherical power? Is it the cylindrical power? If it's a cylindrical power, at what axis? How much has to be ground? All these things have to be told very clearly and explicitly to the manufacturer. That is why we have to do a toric transposition. So what does that do? It splits a clinical prescription into specific separate front and back surfaces, so for us to carve. Okay, so finally what happens? The end result is a manufacturing blueprint for a physical lens carving. Okay, unlike simple transposition, which is just a mathematical modification of the patient's prescription, toric transposition is essentially a guide or a blueprint provided to the manufacturer as to how the physical lens has to be carved. Now let's go into the details of how to do a toric transposition. The first and most important step 1, is to check the sign. The base curve sign and the cylinder sign have to be same. If the base curve sign and the cylinder sign are not same, then we have to do a simple transposition and convert them into similar sign. Okay, this is the first step in our algorithm of toric transposition. Now after finding this, we have to calculate the front surface. The front surface is nothing but the given sphere minus the base curve. I'll tell in detail about how this is arrived, how to do it. Okay. After calculating the front sphere curve, we have to then find out what is the base curve axis. The base curve axis is placed exactly 90 degrees away from the cylinder axis. Okay, and then we calculate the cross curve axis. The cross curve axis is the treated cylinder plus the base curve. Each step I will tell in detail. Just we have to know what are the steps. I am just enumerating the steps. Finally, after calculating all this, we assemble the formula as per what I already told. That is, the numerator having the sphere, the front sphere surface, anterior sphere surface, the denominator having the base curve and its axis, and the cross curve and its axis. So essentially it is 4 steps giving rise to the final 5th step. So I'll again reiterate again. So what is the first step? First step is verify the sign of the base curve and the cylinder curve of the prescription. If both are same, then no problem. If they are different, then we have to do a simple transposition to make both the base curve sign and the cylinder sign similar. Next is calculate the front sphere surface. Third step is rotate the base curve axis 90 degrees away from our prescribed cylinder axis. Calculate the cross curve and finally assemble the formula to get our toric transposition. We just learned the different steps involved in doing toric transposition. Now let's see each and every step in detail. So what does the first step say? The first step asks us to compare the signs of base curve to the sign of the cylinder. This is the golden rule of signs. Okay, we have to compare. So what do we achieve? We have to see whether they match. Suppose the base curve sign and the cylinder sign, that is in the prescription, they match. Then we proceed to the step 2, which is to find out the anterior surface power. What if they don't match? If there is a mismatch, then as I told earlier, we have to do a simple transposition and match the signs before proceeding to step 2. This is a very important step and we have to keep in mind. Never proceed to do a toric transposition before we have achieved a matching of the base curve sign and the cylinder sign of our prescription. Now let's see how to do the calculation of anterior surface power. This is our step 2, that is calculating the anterior surface power. So we have learned that there is something known as a nominal length formula. So what does this nominal length formula says? The nominal length formula says the anterior surface power plus the posterior surface power of the lens is equal to the total power of the lens. Okay, now the posterior surface power is what? The base curve. The base curve is nothing but the posterior surface power of the lens. And the prescription, the spherical part of our prescription, is the total power of the lens. Okay, so as per the nominal length formula, if we have to find out the anterior surface power, all we have to do is subtract this base curve from the total power, and this will give us the anterior surface power. So how do we do it? Anterior surface power is nothing but the total sphere, that is the prescription sphere, minus the base curve, and this is a algebraic subtraction. Okay, so this is how we do a anterior surface power calculation. So let's see how we actually go about doing it. This is a scenario where the clinical sphere, that is the prescription, has +1 and the base curve is -6 diopters. So as per our formula, what does each and everything mean? The spherical power is the total sphere, that is +1. The base curve is nothing but the posterior power, which is -6. So we have to subtract the base curve from the spherical power, which is nothing but +1 minus of -6, which gives us +7. So the +7 diopters is the anterior surface power. So what does this actually mean? This actually means, let's say this anterior surface power here as per our calculation is +7 diopters. Okay, but what is the spherical prescription that we require? We require 1 diopter. So in this +7 diopter lens, we have to remove -6 diopters, so we end up with +1. Okay, so the -6 is ground out of this +7 diopter sphere, so that we end up with a +1 diopter spherical lens. So that is what it means. Okay, so the anterior surface is +7, the posterior surface is -6. End result is a +1 diopter sphere. So we have learnt that toric transposition involves step 1, which is comparing signs of the base curve and the prescription. Okay, then we learnt how to find out the anterior surface power. Now let's put it into use. Okay, so first scenario, what is our first scenario? Which is the green light scenario, that is our prescription sign and the base curve sign are both matching. This is a minus, that is minus. So as per our scenario, it is a match, so there is a green light. We can go ahead and do the step 2. Okay, so what is our target? Our target is +2 diopter sphere, -1 diopter cylinder at 90 degrees. So as per our algorithm, the step 2 means calculating the front sphere. So how do we calculate the front sphere? I already told you the target, which is the total sphere. This is the total sphere +2, and it is subtracted, the base curve is subtracted from the total sphere. So +2, which is this, base curve, which is -2, is subtracted from this total sphere. So +2 minus of -2 becomes again +2, which gives us +4. This will be the anterior surface power. Okay, so this will be in the numerator, that is +4 diopter sphere will be our numerator. Now let's go to step 3. What was step 3? Step 3 is nothing but rotate the base curve axis by 90 degrees compared to the cylindrical prescription. So what is the base curve? Base curve is -2. What is the cylindrical axis? It is 90. So rotating it by 90 degrees gives us 180 degrees. So the first, we have already found out that the numerator is 4 diopter sphere. Now the base curve is -2 at what? 180 degrees. So one part of the denominator we have found out as per our step 3. Now let's go to step 4, that is the cross curve. So how to find out the cross curve? Cross curve is nothing but our prescription, that is the cylindrical prescription, plus our base curve. Okay, so it is again an algebraic sum. So here what is the sphere, the cylinder, it is -1 and the base curve is -2. So we add both, we end up with -3 and the axis is the same. So what is the other part of the denominator? It is -3 into 90 degrees. So let's see how our final formula looks. That is step 5. We have got +4, which is our numerator, anterior surface power, +4 diopter sphere, -2 cylinder at 180, which is 90 degrees away from the cylindrical prescription. And what is the cross curve, which is the more curved surface? It is -3 diopter cylinder at the 90 degrees, that is the prescribed axis. So this is our final result. This is the toric prescription that we have tried to calculate and we have ended up doing a good work. Okay, so what is the final result? It is +4 diopter sphere, that is the anterior surface, -2, which is the base curve rotated at 90 degrees, and cross curve we calculated the sum of the sphere and the base curve, which came to -3 diopter cylinder, the same axis as the prescription. So this is our final toric transposition. Now let's go to a different scenario, the red light scenario. What is a red light scenario? Here if you see, the sign of the prescription and the sign of the base curve are not similar. So we have to take a small detour. What we have to do, since there is a mismatch, we have to do a simple transposition. So what is our targeted data? It is +3 +1 at 90 degrees. So simple transposition, we have learned that it is the algebraic sum of the sphere and the cylinder. So algebraic sum gives us +3 +1, which is +4 diopter sphere. Then we have to flip the cylinder by 90 degrees, the sign of the cylinder. So what have we done? The +1 now becomes -1 cylinder. Okay, then rotate it by 90 degrees. So the new axis becomes 180. So sum of the sphere and cylinder, which leads to +4. Flip the sign. So +1 becomes -1 and rotate it by 90 degrees, which gives us 180. So our new target is +4 sphere -1 cylinder at 180. So this is our target of our lens prescription. Okay, now let's try to achieve a toric transposition as per our target. So we ended up with, after simple transposition, we ended up with +4 diopter sphere -1 diopter cylinder at 180 degrees with a base curve of -2. Now let's go to step 2. What is step 2? Step 2 is nothing but total sphere, which is +4. We subtract the base curve from that, which is minus of -2 again, and which gives us +6 diopter sphere, which is our numerator. Okay, so the anterior spherical surface is +6 diopter sphere. Now we know we have to rotate the base curve by 90 degrees. So it is 180 degree. So we rotate it by 90 degree. Our end result is 90 degrees. So base curve, half of our denominator is base curve, which is -2 diopter cylinder at 90 degrees. Okay, so that part is achieved. Now calculating the cross curve. Cross curve is nothing but our cylindrical prescription plus the base curve, algebraic sum. So -1 plus -2 gives -3. And what is the axis? The axis has to be the same as the prescription, which is 180 degrees. So we have calculated and found out the last part of our formula, which is the cross curve, which is -3 diopter cylinder at 180. So our final prescription as per our toric transposition is +6 diopter sphere, -2 diopter cylinder at 90, -3 diopter cylinder at 180. this is the cross curve, and this is the base curve, and this is the anterior surface power. So we just now saw both the green light scenarios and the red light scenarios, that is when there is a mismatch in the signs and when there is no mismatch in the signs, and also we saw how to do different steps of the toric transposition. So let's do a walkthrough of one example. Okay, so what is the decide prescription? The decide prescription is +4 diopter sphere, -1 cylinder at 180, base curve is -6. So what is the first step? Look for a sign match. So here if we see -1 diopter cylinder and -6 diopter, so there is a match. So this is our green light scenario. So we can simply proceed to step 2, that is calculating the anterior surface power. So how to calculate the anterior surface power? Total power, that is the prescribed power, is +4. Okay, and we have to subtract our base curve from that. Okay, so what is the base curve? Which is -6. So being algebraic subtraction, minus of -6, that gives us +10 diopters. So as per our math, the anterior surface power has to be +10 diopters. Now let's go to the step 3, that is base curve alignment. So we know this is our base curve and this is the prescribed axis. We have to now rotate it 90 degrees away from the prescribed axis. So this is the base curve, which is -6 diopter cylinder. Rotating it by 90 degrees leads us to 90 degree. So the other half of our denominator will end up being -6, that is our base curve is -6 diopter cylinder at 90 degrees. Finally, cross curve calculation. How do you calculate the cross curve? Cross curve is nothing but the base curve plus the cylinder in the prescription. So -6 plus -1, which gives us -7 diopter cylinder, and the axis is the same as the prescription. Prescription is 180, so this axis also will be 180. So the next half of our toric cross curve denominator will be -7 diopter cylinder at 180 degrees. Okay, so what is the final assembly? This was our input, that is +1, -1, 180 and base curve at -6. So after doing a toric transposition, we arrived at a frontal anterior surface power as +10 diopter sphere, base curve shifted 90 degrees from the cylindrical prescription, cross curve calculated as a sum of base curve and the cylindrical prescription, which is -7 diopter cylinder, and the axis is the same as the prescription. So back toric will be 180 degrees. So this is the base curve, this is the cross curve. Okay, this is just the final assembly that we have tried to achieve by doing a toric transposition. Now let's see another scenario. Here this scenario is a sign mismatch, or the red light scenario, which we earlier talked about. So what is this red light scenario? Here there is a spherical prescription, which is +1, and the cylindrical prescription is +2, whereas the base curve is -6. So there is a sign mismatch. This is plus and this is minus. So how do we solve this conflict? We have to do a simple transposition. So the simple transposition, what are the steps of doing a simple transposition? We have to do an algebraic sum of the sphere and the cylinder, which leads us to +3 diopter sphere. We change the sign of the cylinder, so instead of +2, that has become -2 diopter cylinder, and rotate it by 90 degrees. So the new axis is 75. So what is the target? The new target is not this. The new target is not this. It is this, that we are going to do toric transposition. We are trying to achieve what? we are trying to achieve plus 3 diopter sphere and minus 2 cylinder at 75 degrees. Okay, so now since we have resolved the sign mismatch, let's go to our step 2. So what is the step 2? Step 2 is calculating the anterior surface power. Okay, so this is our working power that we have to achieve. So anterior surface power is nothing but sum of the total sphere minus the base curve. So plus 3 minus of minus 6, we end up with plus 9 diopter sphere. And base curve, we have to rotate it by 90 degrees. So since after simple transposition we got 75, by rotating it we get 165 as the new axis. So the base curve is minus 6 diopter cylinder at 165 degrees. Cross curve. How do we calculate the cross curve? Sum of the base curve and the prescription. So it is minus 6 plus minus 2, which gives to minus 8. So minus 8 diopter cylinder in the prescribed axis, that is 75. Okay, so we have calculated anterior surface power, we have calculated the base curve, and we have calculated the cross curve. So let's go to assembling our thing. So what do we get at our final assembly? Plus 9 diopter sphere, which is the anterior surface power, and minus 6 diopter cylinder at 165 degrees and minus 8 diopter cylinder at 75 degrees. Please don't get confused with this because this is not the original input. After simple transposition, we have got the input as plus 3 diopter sphere minus 2 diopter cylinder at 75 degrees. So now you can see that our cross curve, the axis is matching with this, and the base curve is rotated by 90 degrees. Okay, don't get confused that these two are different. Okay, these two will be different because this is not the target, this is the new target which we have got after simple transposition. So as per our final thing, we have achieved the cross curve is of the same axis as the prescription, and the base curve is rotated by 90 degrees. So I'll finally give a complete process pipeline of our toric transposition. Okay, so what is the process of doing a toric transposition? We have the prescription, we do a analysis of sign matching. If the sign matches, then we proceed. If they don't match, then we do a simple transposition to make them match. So they again come into this, and once the signs start matching, we do two things. One is to calculate the anterior surface power, which is nothing but the sphere minus the base curve, and we rotate the base curve by 90 degrees, and we calculate the cross curve, which is the sum of the base curve and the cylinder power, and keep it at the same axis as the prescription. Finally, we put all this in our sandwich to arrive at our assembly, which is the anterior surface power by base curve rotated by 90 degrees and cross curve in the same axis as the sphere, the same axis as the cylinder in the prescription. So this is the complete process of doing a toric transposition. Okay, so finally what have we achieved? This is the clinical prescription, and by doing all these steps of toric transposition algorithm, we are bridging the gap from the clinical prescription to the optical lab for producing or manufacturing the lens in the final form.